Hello, pre-calculus students, and welcome to our continuing series of videos here on combinatorics. And this is really an introduction to combinatorics here. So it says this question, how many ways can we rearrange these letters, or how many ways can these letters be rearranged? So let's start with sun. Well, sun can be written this way, S-O-N, S-N-O, N-O-S, N-S-O, O-S-N, and O-N-S. So we can literally just count the number of ways, 1, 2, 3, 4, 5, 6 different ways to do this. Okay. Now, this is really the same as having 3 people in a race finishing first, second, and third. It's just one of the things about studying combinatorics and discrete math is how do we organize and how do we make connection between different questions? Because a lot of times it looks like it's a different question, it's an entirely different topic, but it turns out that it's really asking the same thing. So this is really just 3 factorial. Okay? This is the same as finishing as 3 people finishing first through third. Okay? Really just the same way. And again, the idea is we want to generalize and abstract these concepts so that we don't have to keep counting these tediously every single time. So let's look at the next examples. How many ways can we reorder these different letters? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 of them. So there are 8 factorial ways. And whatever this number is, I mean, I almost don't care, it almost doesn't matter. What's really important here is that we get this, we were able to do this computation, or we know that this is the method that needs to be done. Okay. Let's go on. Next one, how many ways can we reorder the letters M-O-M or mom? Now, you want to say 3 factorial. Is it 3 factorial? Well, it seems like it would be. It's the same as sun. Sun has 3 letters, mom has 3 letters. But this is actually not exactly the same thing. And the reason is, and let me show you and illustrate by using different colors here. So if I make a distinction between the first M and the second M, so I can spell M-O-M that way. I can also say M, then the red M, then the O. Then I can say the O and the red M, then the purple M. Then I can say the O, the purple M, and then the red M. And I can also start things off with the red M, the O, purple M, red M, purple M, O. So now I've listed this out. There are 1, 2, 3, 4, 5, 6 different ways to write this. But if you notice, some of the words are the same. This here is the same, that they both say mom. This term here and this case here, they're both the same. They both spell MMO. And the same thing here for these 2 examples. Okay. They both say OMM. Okay. And so there are 6 ways, but they can be grouped into identical pairs. In pairs, so this is pairs of 2. So really there's just 3 ways. So there's 6 over 2, so that's just 3 different ways. Okay, and that's really the answer. And we want to think about this. Well, is it 3 factorial over 2, 3 factorial over 2 factorial? How does this really work? Well, let's take a look at another example where we see another case of this. And let me switch boards here. Keep that there. The third word we're asked to do here is Everest. E-V-E-R-E-S-T. So let's see. So we can do this with the word Everest. And what I've done here is I've just written out every single possible combination with leaving the the VRST the same. And you can see that I can sort of just move a bunch of the E's around. So I put the blue E in front, put the purple E here, then the red E, and then I can also switch them. Okay. Then I can put the red E in front, and then I can put the blue one here, and then I can put the purple one here. Okay. So those are all the ways that I could do this with keeping the VRST the same. So this is really six identical results. In other words, if I were to use 7 factorial, then what I'm doing is I'm counting these all here as 6 different results, but they really should just be counted as one result. Okay, so in order to get an accurate answer here, I have to do 7 factorial divided by 6. And more importantly, we want to think in general terms. We want to say that this is really 7 factorial divided by 3 factorial, because I have one E that repeats 3 times, and there's 3 factorial ways of rearranging them. So if you just look at the E's, there are 3 factorial ways of rearranging them. And finally, I want to show you another way that we can approach this is, let's just forget about the E's. Let's just think there are 7 slots, 1, 2, 3, 4, 5, 6, 7 different slots. And I have these 4 letters, V, R, S, T. How many ways can I place them into these 7 slots? So I have 7 slots. Okay. How many ways to place 4 letters, V, R, S, T? Well, and we want to draw a comparison to some other problems. And this is really a very similar case to what we did on the first page, which is saying I have 10 people in a race. How many ways are there for me to place 3 of them? And we learned that was 10 factorial over 10 minus 3 factorial. And in this case, this is 7 factorial over 7 minus 4 factorial. And it turns out this is 7 factorial over 3 factorial, which matches up with the other 2 ways that we did this too. And so one of the beautiful and also frustrating things about this process, these concepts that we learn, is that there's many ways to solve a problem, and you have to be able to identify one of the correct ways, and you're never quite sure, there's never like 100% sure that you're correct unless you just do a lot of these and you practice and you find multiple ways to solve the same problem. Okay, and it has to sort of just make sense to you in your head. Okay, well, thank you for watching this video. This is a tough topic. The algebra is the computation is very simple, but the critical thinking is in fact very, very challenging. All right. Now, before we end, I want to do one more example. This time with some kind of a more difficult choice that makes us think even more. So this time we have this word here. Well, there's 1, 2, 3, 4, 5, 6, 7, 8 letters, so we think it's 8 factorial. But we know that these 2 O's here can be interchanged, so we have to divide by that. And then the 2 L's can also be interchanged, and the 2 U's could also be interchanged. So the solution to this is actually 8 factorial over 2 factorial times 2 factorial times 2 factorial. Okay. And because there's many different ways for us to rearrange the repeated letters. So I could have taken these 2 O's and swapped them and left the U's and the L's the same. I could take in these 2 O's and swap them and then swap one more of the U's. So this is another way. Okay. And then I could, swap the O's, swap the U's, but not swap the L's. So there's all these combinations, and turns out there's really 8 ways for me to do that. And so this is going to be your answer. And you have to be careful. These two are not the same thing. 2 factorial, 2 factorial, 2 factorial. This is really just 2 times 2 times 2. So this is 8 factorial over 2 factorial. Sorry, 8 factorial over 8, okay, which is the same thing as 7 factorial. So both of these answers would be acceptable in this case. And once again, these are difficult, challenging concepts. You really have to work at them, spend a lot of time thinking about this, and try to organize it in your brain in a way that makes sense to you. All right, well, thank you for watching. Have a wonderful day. Make sure to continue watching the remaining videos.